Now, this is part 2 of problems on unit and measurements. Let's take number 1. Which of the following are derived units? I meter, II coulomb, III kilogram, IV amps, V joules. Now, we'll talk about fundamental and derived quantity, also fundamental and derived units. Now, derived units are the simple combination of the fundamental units. These are the 7 fundamental units. Fundamental units. We have kilogram for mass, meter for length, second for time, amps for current, Kelvin for temperature or degree Celsius, mole for amount of substance, candela for luminous intensity. So these are the 7 basic units, that is the SI units. So if you combine any of this, you get fundamental and you get derived units. Now let's take the first one, meter. As we can see, meter is here. That means it is fundamental units. So answer cannot be 1. So it is fundamental units. So this cannot be the answer. So now, coulomb, the second one is coulomb. Coulomb is unit for charge, and Q is equals to IT. So that means Q, coulomb, is equals to current times time. I is current, T is time. So A is amps, S is second. Do you see we have combined A and S? We have combined amps and seconds. So by combining the units, it is derived units. That means the second one is a derived unit. So this is a derived unit. So now I I. So kilogram. Now kilogram is part of the fundamental here. So that means it cannot be derived. So kilogram is part of the fundamental. So it cannot be derived, as you can see. So that's how you choose answer. You screen some out. IV amps, that is ampere, so is unit for current, is also part of the fundamental units. That means it cannot be derived. Then we have joules. Joules is the unit for energy, just like work done is force times displacement. So that means force is kilogram meter per second square times displacement is in meter. So if all this represent Newton, so we have Newton meter. You can see we have combined units here, not just one. So by combining units, kilogram is fundamental, meter is fundamental, second is fundamental. So by combining units, 1 or 2, then it is derived quantity. That means this is also derived. So the ones that are derived are coulomb and joules. So that means the correct answer is B. The correct answer is B. That is coulomb and joule. So that is number 1. Now let's see number 2. Which of the following are derived quantity? Now, as we have derived units, we also have derived quantity. So derived quantity are the simple combination of the fundamental quantity, like quantity that produce the unit of kilogram is mass, y this is length, this is time, current, temperature, mole, amount of substance, luminous intensity, candela. Now those are the quantity that give us that unit. So which of the following are derived quantity? So number one, thrust. Now for thrust is a force which has the units Newton. So if you say thrust, know that is a kind of force and the unit is Newton. And what makes up Newton? Force is mass times acceleration. That is kilogram meter per second square. That means this is a derived quantity. Since we have a derived unit, so it's also a derived quantity. So that means thrust is not a fundamental quantity. It's not part of this 7. So it's not part of this 7: mass, length, time, current, temperature, amount of substance, luminous intensity. Since it's not part, then it's a derived quantity. So that means yeah, it's derived quantity. Then it is derived. So it's part of our answer. Since question say which of the following are derived, so it is derived. Then I thrust, I temperature. Now temperature is part of the fundamental quantity, so it is not derived. It is part of the fundamental quantity, so this cannot be derived. Now area, we know that area is length times length. Length is in meter, another length meter, so area is meter square. So an area is not part of this 7 fundamental quantity. Also the unit is derived, so it will be fundamental quantity, and that means area is derived quantity. So area is derived. Why? Because it's combination of fundamental quantity. So and it is not part of those 7 fundamental quantity, so it is derived. So now pressure is also not part of this 7 fundamental quantity, because derived quantity is a simple combination of fundamental. So pressure is force over area. Pressure is force over area, and force is Newton, area is meter square, so that is Newton per meter square. So it is not fundamental, it is derived. That means pressure is derived. Correct. Now the correct answer here is 1, 3 and 4. So that means the correct answer is C, 1, 3 and 4. Now number 3. Number 3. The derived dimension ml, so that's dimension. uh, I want to clear the canvas. So number 3, the derived dimension ml square t raised to power minus 2 is a dimension of what? Now let's test it one by one. Now the first one given is acceleration. Acceleration is velocity over time, and we have known that velocity is displacement over time. So velocity itself is displacement over time, also divided by time. And we know that the dimension for displacement is a kind of length, so that will be L. Time is t divided by t over 1, that is divided by another time. So that means this is L over t times 1 over t. So because if division change to times, it will turn upside down. So that is 1 over t square, L over t square, which is Lt raised to power minus 2. So that means acceleration is Lt raised to power minus 2, or dimension of acceleration is m raised to power 0, L raised to power 1, t raised to power minus 2. So acceleration has 0 dimension in m, 1 dimension in length, minus 2 dimension in t. So that means it does not tally with this. So acceleration cannot give us that dimension. So acceleration is wrong. So that means the dimension cannot be for acceleration. So this is wrong. Now the second one is tug. Tug. Tug is force times arm length. Force times arm length. So force times arm length. So that means tug force we know is mass times acceleration times arm length is a length, so that will be L. And we know that mass is capital M. We have found acceleration now, Lt raised to power minus 2 times another length. So that means tug is equals to ml square, because this is power 1, this is power 1, add it together, ml square t raised to power minus 2. So that means the dimension for tug is ml square t raised to power minus 2. That means the second one is correct. So tally with that. Then the third one, energy. Energy, we can represent energy as work. So work is force times displacement. And what is force? Force is mass times acceleration times displacement. So mass, we have known that the dimension of m is mass is m. Acceleration, we have found it now, Lt raised by minus 2. Then displacement is L. So which is ml square t raised to power minus 2, also give us the same answer. So that means the correct answer, energy, is also this. That means 3, the correct answer 1 and 2. 1 is not part, 2 and 3 is the correct answer. So which one give us the option 2 and 3? D. So that means the correct answer is D, 2 and 3. So it gives us the answer. Then let's say number 4. Number 4. Which of the following are not fundamental units? Now, fundamental units are kilogram. We listed them before. Kilogram, meter, second, amps, candela, mole, Kelvin. So anyone that is not part of these fundamental units are not the answer. Now, which of the following are not fundamental units? As we can see, Kelvin, Kelvin is here, so it's a fundamental unit. Newton is not here, so it's not a fundamental unit, because Newton is kilogram meter per second square, so it is a derived unit, so it cannot be the answer. Then second is here, so it's a fundamental unit. Radian is not here, so it's not a fundamental unit. And radian is equals to theta over time, so that is the angular velocity. So angular velocity is theta over time. So radian, the unit radian is per second, so this is 1 over s, that is s raised to power minus 1, so it is a derived unit. So that means we cannot use it here. So that means we cannot use radian is not part of the answer. So the one that are fundamental here are Kelvin and second, so 1 and 3. So that means the correct answer is A, 1 and 3. Which of the following are not? Which of the following are not? So A is fundamental, as in I is fundamental, I is fundamental, and not fundamental. The one that are not fundamental are Newton and radian, that is 2 and 4. So the correct answer is B. Now the number 5. The unit of momentum is, now what is momentum? Momentum is mass times velocity. Now we already know that momentum, we can use this symbol, is equals to mass is in kilogram, velocity is meter per second. So that means momentum should be kilogram meter per second. But we can say impulse. What is impulse? Impulse is force times time. So now if you look at this impulse, the unit is Newton second. That means impulse can also be changed to momentum, that is mass times velocity, as in this one. So let's see. So impulse I is equals to force times time, and impulse is equals to, what is force? Force is mass times acceleration, then times time. And what is acceleration? We can break it down. Acceleration is mass times, then acceleration here is velocity over time, then times time. You can see time will cancel out here, so time will cancel out, so it remains impulse is equals to mass times velocity, so which is kilogram meter per second, which is also the same as momentum. So and you know that impulse initially I write it as force times time, which is Newton second. Newton times time, that is Newton seconds. That means momentum can also be in Newton second. So that means the correct answer here is B. Correct answer is B. So joule per second is power. So we should analyze the answer one by one. Joule per second, power is work over time, and unit for work is joule per second. So that will be joule slash s, or joule s raised to power minus 1. Now B is the correct answer. Then Newton per second is like saying force over time, and the one we need is force times time. Another one is Newton meter second. That is like force times displacement times time. So none of it is right, but the correct answer is B. So now let's see another question. Now this is another question. A student measures the internal and external diameters of a cylinder vessel as 100 plus or minus 1 millimeter. That is the internal diameter, and external as 104 plus or minus 1 millimeter respectively. The possible error in the determination of the thickness of the thickness of the vessel is, now this is under error analysis. So we have given we have the internal diameter. Let me call that one D1. So internal diameter D1 is equals to 100 plus or minus 1 millimeter, and external diameter, let me call that one D2 for external diameter, that is 104 plus or minus 1 millimeter. Now the possible error in determination of the thickness of the vessel. Now thickness, let's say T, will be equals to the external diameter minus the internal diameter. If you subtract the two, you are going to get the thickness. So you get thickness for the two. So now in this case, according to this, for the internal diameter, D1, so the values we have here, so the true D, which is the first one here, so is the true diameter. That means that is 100. So that is a true diameter. Why the second one is change in D, that is change in D1 is equals to plus or minus 1. So let's say plus 1. So I'm taking the maximum here. Also the external diameter D2 will be 104, and the delta D2 is equals to plus 1 also, which is the second one here. So to find the error in the determination of the thickness, so the thickness of the diameter here, T, is equals to 104 minus 100. So that means T is equals to 4. So the thickness will be 4 millimeter. Now in the diameter, the thickness in the diameter, the difference in the diameter here, that is changing uh, to find the down. We have t is equals to d2 minus d1 based on what we show on the error analysis. So this, I said we have t plus percentage error change in time, that is delta t. Then we have d2 also plus change in d2, then minus d1 change in d1, that is plus change in d1. So in this case, let's use plus or minus because we are finding the error, so we can take the maximum error. And what we did then is we said t is common. Yeah, if t is common, so we can have 1 plus delta t over t equals to d2 into 1 plus delta d2 over d2 plus or minus d1 into 1 plus or minus delta d1 over d1. So we also expand, so this is t 1 plus delta t over t is equals to d2. What is d2? So d2 times, that is plus or minus d1, expand the bracket, so that will be d2 plus or minus d2 times this, so that will be delta d2, then plus or minus, open a bracket here again, d1 plus or minus delta d1, if you open the bracket here also. So this will be t 1 plus delta t over t is equals to plus d2 plus or minus d1 plus or minus delta d2 plus or minus delta d1. So you can expand the bracket here also, so that will be t plus delta t will be equals to d, we already know that d2 plus or minus d1, so if we check from beginning is t, so that means we will have, let me clear the canvas from here so that I will show that part. Let me clear this. Now from here, this is over t. Let me write it, t brackets 1 plus, I'm not expanding this again, so I want to show something that t 1 plus delta t over t is equals to, now d2 plus d1 plus or minus d1, if you look at it here is t, so that means this will be t plus delta d2, that is plus or minus delta d2 plus or minus delta d1. So now we can take this t to the other side, so we can expand. If we expand here, we'll get t plus, as in t times 1, t plus delta t is equals to t plus or minus delta d2 plus or minus delta d1. So if you collect like terms, this t will come to this side, so t minus t will be 0. So that means it will be like t plus delta t minus t is equals to plus or minus delta t2 plus or minus delta d1. So t will cancel out, so it will remain delta t. So that is a possible error in t. So finally, yeah, we have the t, that is delta t, is equals to plus or minus delta d2 plus or minus delta d1. So that means delta t, so maximum possible error here, maximum possible error in thickness, maximum possible error in thickness is equals to that means the t is maximum possible error in thickness will be equals to delta, that is maximum possible error in diameter 2 plus maximum possible error in diameter 1, so sum of the individual error. So we've done this in previous video, so that is how we can get our maximum error in thickness. So but the real thickness here is 4, so the maximum error in the thickness is t, same dt. But if you look at the question here, we already see that this one is our maximum error for d1 and d2. So that means according to the question, maximum error in d1 is 1 and maximum error, sorry, this one there is plus or minus, so maximum error, I'm only considering plus here, no, it's plus or minus, but the maximum, so to be plus or minus delta 2 plus delta 1. That means maximum possible error in d1 is equals to 1, is here already, that is plus 1 and plus 1, we take the plus, so that means maximum error in time is equals to plus or minus 1, that is this one, plus 1. So maximum possible error in determination of the thickness, so maximum possible error in the thickness is plus or minus 2. So that is what the question asks for. But the thickness, if you want to find the thickness will be equals to this result, that is 4. So normally it should be t plus or minus delta t. So if you want to find the real thickness, yeah, so that means the real thickness, that is t minus d2 minus d1, so will give us this, which is the thickness. So that means if question asks for thickness will have been t equals to, as in the error in thickness will have been, if it is not error in the, yeah, this one is possible error in the thickness, but the real thickness, the measurement in the thickness can be t, that is 4 plus or minus 0 point plus or minus 2. Yeah, that is the thing. I said this one now will represent the thickness. So thickness can be, measurement of the thickness can be this, but this one is the possible error in the thickness. So measurement of the thickness can be 4 plus or minus 2 millimeter, as in this, that is t plus the t. So there are two questions that you can have here. So if question asks, what this question asks here now, what question asks here is the possible error in the determination of the thickness. That is possible error in the determination of the thickness, that is plus or minus 2 millimeter. So but if the question asks for, the actual thickness, that is the measurement the actual thickness can be, that is 4 plus or minus 2. But the one we are using here is the B, so that means is the A. So the correct answer is A, which is this one. So that is the possible error in determination of the thickness. So like that. Possible error in thickness is equals to plus or minus 2. While thickness will be measured as 4 plus or minus 2 millimeter. So that is the difference. So if question asks for the measurements of the thickness, it will be this. But possible error in the thickness, so is this. So the one the question asks for is this A. So the correct answer is A. Now let's see another question. Let's see another question. And before we see a question, I only derive how we got that length. So if I am to solve if I am to solve the question without passing through those proofs, you can actually do it straight. You will know that we have shown now that possible error in C will be equals to possible error in diameter plus possible error in the second diameter. So you can use this direct without passing all the stage, but I prove why we got this one. So but as you know it now, you can use it to solve. So that means you can find your dt direct, that is 1 plus 1. So maximum possible error in thickness is 2 plus or minus 2 millimeter. So you can actually solve it straight like this. But what I did first is showing this how we got that result. And the real thickness can be 4 plus or minus 2 millimeter. Thickness can be measured as this. So we've shown everything, so that you will not think it's long. So I actually prove. Now let's take another problem. So yeah, now number 6. Yeah, what is the dimension of power? Dimension of power is, we know that power is work over time, and work is force times displacement over time. So we know dimension of force as ml t raised to power minus 2, and displacement as l over time t. So this will be ml square t raised to power minus 3, because this one will go up. So that means the correct answer is A. So A is correct. 7. In which of the following physical quantities are the units correctly indicated? Weight is in Newton, correct. Momentum, kilogram meter per second, we've talked about that, correct. Energy, force times displacement, that will be force times displacement. Force is Newton, displacement is meter, so Newton meter, correct. Acceleration is meter per second square, so that one is wrong. So that means the correct answer will be 1, 2 and 3. Be 1, 2, 3. Oh, sorry. We can still solve the acceleration. What they ask is acceleration. So you know that force is equals to mass times acceleration. That means from here, acceleration can be force over mass. That means force is in Newton and mass is in kilogram. That means acceleration here can be Newton per kilogram, which is actually correct. Yeah. So that means everything is correct. So the correct answer is D. So 1, 2, 3 and 4. So everything is correct. 8. The watt is equivalent to, watts is unit for power. Power is work over time, and work is in joule. Time is in second. That will be joule per second. So that means it should be joule per second, so not joule second. So that joule per second, joule is also force. So if I break it down, so I'm working towards the answer. So we have seen power now, but according to the answer, that means they still express it further. According to the, we have power, work over time. Power, force times displacement over time, because work is force times displacement. So power is Newton, displacement meter over time, that is second. So that will be Newton meter per second, so which is actually A. That means A is correct. Yeah. So we'll solve more in another video. Thank you.